Hi everyone, my name is Tanish and along with Asmita, we're doing a final project presentation for the data center scale computing course in which we have built a carbon aware job scheduler system.
The problem currently being faced is that modern data centers consume massive electricity, much of which comes from carbon intensive sources during peak demand hours. Running compute heavy jobs during these high carbon periods significantly increase CO2 emissions. This is the core motivation for our project that implements an intelligent carbon aware job scheduler that launches jobs when carbon intensity is low or renewable energy availability is high. This includes monitoring real time carbon intensity data, delaying low urgency jobs, immediately executing high urgency jobs, track job execution states, and provide an interface for job submission and monitoring. These are the software and hardware components we have used in our project that make us successfully satisfy the four requirements of the listed components of API interfaces by Fast API, message queues by RabbitMQ, databases using Postgres, message marshalling or encoding using Celery.
Okay, so now I'll walk you guys through the architecture of our carbon aware scheduler. We designed this using a modular layered approach to ensure scalability. Starting at the top, we have the presentation layer where the user interacts with the system via a streamlit dashboard. Instead of processing jobs immediately, the API pushes them into RabbitMQ, our message broker. This is crucial because it decouples submission from execution, allowing the system to handle bursts of traffic without crashing. In the application logic layer, we have two key background services running on Celery. The carbon collector, which periodically fetches real-time grid data from the electricity map API, and the scheduler, which checks the queue and makes intelligent decisions. That is the grid clean enough for this job? And if the conditions are met, the job is sent to the worker service for execution. Finally, all the states, such as the job history, the carbon logs, they're all persisted in the PostgreSQL database, ensuring we have a reliable record of every decision the system makes. This is just basically how the interaction is taking place, a simplified version of the architecture. And yeah, moving to the debugging. So for debugging, we have three main things to debug. That is the worker, which was debugged using Flower, which is the Celery's built-in monitoring system. And then the carbon data collector was an API, so we logged the responses and timestamps to verify the correctness of the fetch data. And then for the message queuing, we use the RabbitMQ's management UI to inspect the queues, message backlogs, and the consumer health.
Testing in our project primarily includes API testing, where we use Swagger UI and curl command line requests for manual verification. Second is load testing, where we evaluate system robustness under high job submission load. This is done by submitting 80 to 100 jobs in rapid succession using a Python load test script, where each job is inserted into the queue as fast as possible to simulate real world batch submissions.
Okay, so now I'll walk you guys through a live demo of our project. Yeah, so this is our home page, and we can clearly see the current grid status here. So this is basically the value that is fetched from the carbon electricity map API. This is the carbon intensity for the US West 1 region, right? Okay, so now let's submit a job. We'll submit a high urgency job first with the default resources required, right? So this is a critical production level task, and it should run immediately. It should be picked up immediately regardless of the grid intensity, and which is exactly what is happening over here. So we can see it got added at 555, that is right now, and it even started executing immediately. So yep, okay. So meanwhile this is executing, what we can do is we can submit a low urgency level job as well. So the low urgency job has no deadline and default resources. And yeah, okay. So yeah, we can see the high level job got executed and completed ASAP. So the low urgency job should only run when the grid is very clean. That is below 300. The value should be below 300, the carbon intensity. And if the grid is dirty right now, which it is in a moderate level, the job will wait, which is exactly what is happening. The job is in the waiting state. And okay, so finally, let me show you a low level job having a deadline, right? So I've set a deadline for 30 minutes. And if I submit a job, right? So what will happen is now, even though it's marked as low urgency, we're setting a tight deadline, and the scheduler should recognize this constraint and prioritize it, which is exactly what has happened over here. It got created and it started executing as well. So Yeah, so this is our project, and what we demonstrated was the core value in which the intelligent automated decision making that balances performance requirements with environmental responsibility as well. Thank you.